Hello everyone, welcome back. This is Engineer Hussein Mwasapi. Alright, so in this video, we're going to look at more conditions involving alpha and beta roots. So if you didn't watch that previous video on alpha and beta roots where we looked at the application of alpha and beta roots, I'd advise that you go back to the playlist and check it out. Alright, so before we begin, do not forget to subscribe, hit the notification bell icon, and stay updated. All right, let's get to it. So I basically want you to understand this with an example. So from one of the demands that your friend gave, we have this question to say. It says the roots of the equation x squared plus 7x minus 2 is equal to 0 are alpha and beta. So I've been told the roots of this particular equation we have are literally alpha and beta. Now we need to find the values of alpha squared plus beta squared and alpha squared beta squared. Not only that, hence we need to find a quadratic equation whose roots are alpha squared and beta squared. All right, so basically we'll start by finding what they want us to find. Boom. Let's find alpha squared plus beta squared. But before even finding that, we need to remember something. We're having the quadratic equation as x squared plus 7x minus 2 is equal to 0. Now, from the standard form of the quadratic equation, we know that we should have ax squared plus bx plus c is equal to what? 0, of which the coefficient of the x squared term, in this case, is 1. Now, this information tells us to say that the value of a is 1, the value of b is 7, and the value of c is literally negative 2. With this in mind, we can also hold true for the conditions of alpha and beta. Now, the conditions we have are as follow. Forgive my handwriting. It's a bit romantic at times. So the conditions that we have are that, firstly, alpha plus beta should give us minus b over a. So we know minus b, that's the minus of b, which is 7, over a, which is 1, which gives us literally minus 7. So that is what the sum of the roots are. And then we also need to hold the second condition, which is the product of the roots. What is alpha beta? Alpha beta is c over a. So the value of c is literally minus 2. The value of a is 1. Basically, we get a minus 2 as the product of the roots. Now, with that in mind, we can go back to what we need. We now want to find the value of alpha squared plus beta squared. Now, in most cases, we can derive this, but for those of you who have gained the solution to alpha squared plus beta squared, you can always write it. But basically, how this came about was that you have alpha plus beta raised to 2. And then when you expand this, you have alpha squared plus 2 alpha beta plus beta squared. Now remember, this is your question. So you want to get something that looks like this from your expansion. But remember, you have created an equation. So you need to hold true. So if I had to flip this equation, I have alpha squared plus 2 alpha beta plus beta squared being equal to alpha plus what? Beta squared. So like my interest is to have alpha squared plus beta squared. So this will be equal to alpha plus beta squared. Then the positive 2 flies and goes the other side. And you have minus 2 alpha beta. So this literally just tells you to say that alpha squared plus beta squared is always equal to alpha plus beta squared minus 2 alpha beta. Now, for those of you who, I don't want to use the term to say don't want to solve, but I'll say maybe in case you run out of time and you're computing, you can always just remember that it will always be this. Yeah, it will always be that. Anyway, away from that, that is how we get alpha squared plus beta squared. So we need to find alpha squared plus beta squared, which is what we're doing now. So alpha squared plus beta squared is equal to alpha plus beta. We compute that alpha plus beta is minus 7, so we say squared minus 2, then the product is minus 2. So I get alpha squared plus beta squared being equal to, if I raise this, I get a 49. So I get 49, then the minus 2 can multiply the minus 2, I get a plus 4. So I get like alpha squared plus beta squared being equal to 49 plus 4. That gives me 53. So that is basically the answer to our first evaluation. So this is like the sum of the roots of the root of which first root is alpha squared, and then it's going like beta squared. Now the second one is saying find the values of alpha squared and beta squared, as well as alpha squared, beta squared. So I want to now find the value of alpha squared, beta squared. So for this guy, you can easily just factorize it, or factorize it and then write it like that. Or if you want, you can just write it as alpha, beta, then square it like that if you want. So this will basically give you like the product of the roots, which is like minus 2, then square it. So you get literally a 4 as a value of the product of your roots. So now that you have that, you have this other portion which says, hence, find the quadratic equation whose roots are alpha squared and what? Beta squared. So now to find the quadratic equation, we know that it should look something like this. Now, every time they ask you to find the quadratic equation given some roots, remember it should always look like this. It should always look like x squared minus the sum of roots x plus product of roots, and this should always equal to what? 0. So this is literally the equation for a quadratic equation whose roots are given, of which you want to find. Now, you have been told that find the quadratic equation. Now, what are the roots of this same quadratic equation you're finding? Whose roots is alpha and what? Beta. So from this equation you're finding, you need to find the sum of the roots. Now, the sum of alpha squared and beta squared, if we do up a data, you're looking for alpha squared plus what? Beta squared. Now, if you can recall, we found the sum of these roots here. Yeah, these roots. We have 53 as the answer. 53. That's the sum of the roots. And then we also need the product of the roots. So I need alpha squared, beta squared. Now this alpha squared and beta squared, I'm not really picking it just from my head. I'm getting it from the question. I've been told to find the quadratic equation whose roots are alpha squared and what? Beta squared. So now for the product of the roots, if you can recall from what we did, the product was found to be what? 4. So basically the product is 4. So I can just get those values and say, anyway, now my quadratic equation is going to be x squared minus the sum of the roots, which is 53, then put my x there, plus the product of roots, which is what? 4 is equal to what? 0. So literally this is just like x squared minus 53, x plus like 4, and then it's equal to what? 0. And that is you solving your question like a pro that you are. Anyway, so other than that, we now move on to another question. So in this question, they're saying the roots of the equation. This is the equation we have. So we have the equation x squared plus kx plus 28 is equal to 0. And now the roots are alpha. So we've been given the roots are alpha and alpha plus what? 3. So now they're saying find the value of k. Now to find the value of k, you first have to find the roots of the equation. So you know that we're going to create the equations, guys. So we first have to now create an equation with the sum of the roots. So we know that sum of roots is equal to negative b over what? A. Now from this parent equation that we have, it's easy for us to know the value of a. The value of a will be there, b will be there, and c will be there. So what are the sum of the roots? Remember, the roots that we have are these. So I'm going to say alpha and the other roots. I'm going to say plus alpha plus 3 should give me negative b over a. Now alpha plus alpha is 2 alpha plus 3. Then negative b, so negative, the value of b is k, over a, which is 1. So I have 2 alpha plus 3 being equal to negative what? K. So this is like equation number what? Number 1. So this is going to be equation number 1. So once we have that equation, now we need to look for what? The product of the roots. So now the second equation is coming from what? The product of roots. Now the product of roots is equal to C over what? C over A. That is the product of the what? The roots. So the product of the roots we're having alpha and alpha plus 3. Yeah, those are the roots. So we're going to say alpha times alpha plus 3 is equal to C over A. Then I can multiply alpha by alpha and alpha by 3. Then alpha by alpha, that's like alpha squared. Then alpha by 3, that's like 3 alphas. Then it's equal to like C. The value of C, guys, is 28. So you get like 28 there. Say over A, it's like the coefficient of the x squared term. So I put a 1. So it's going to be like x squared plus, sorry, not x, alpha squared plus 3 alpha being equal to 28. This would be equation number 2. Okay, so I want you guys to see this cleanly. So let me put the equations on the next part of the screen. So I'm having equation 1, which is like 2 alpha plus 3 is equal to negative k. This is equation number 1. Then equation number 2 is like alpha squared plus 3 alpha is equal to 28. Equation number 2. All right, now that we have that equation, what do? We can solve these equations simultaneously and determine the value of k. We can make alpha the subject of formula in equation number 1. This is equation number 1, guys. So it's going to be 2 alpha is equal to minus k. 3 flies, and this will be minus 3. Then you have over 2. Then you have alpha being equal to minus k minus 3 over 2. Like that. Now, you send the alpha in equation number 2. So I now know that my alpha here is equivalent to this. So I'll be having like minus k minus 3 over 2 squared plus 3. Then alpha is minus k minus 3 over 2 being equal to 28. Now I have to expand this because now I'm having that 2. 2 is going to do a leg on this question. All right, so what are we going to do? So we're just going to take 4 out. So the 2 goes to minus k minus 3. That makes it squared over 2. As 3 can multiply each particular element here. So you can have like minus, or I can do it in this way. I'll say plus 3 times minus k minus 3 over 2 being equal to, this is going to be 2 squared, sorry, being equal to 28, like that. So with that in mind, what I can do is I can expand this like a square da kappa. So this is like data for this guy here. Can expand it, so like we're having minus k minus 3 squared. So this is like minus k minus 3 times minus k minus 3. So it's like minus k times minus k minus 3. Then it's the minus 3 now participating. So minus 3 times minus k minus 3. So minus k times minus k, that's k squared. Minus k times minus 3 is plus 3k. Then minus 3 times minus k is plus 3k. And minus 3 times minus 3, that's 9. So you get like k squared plus 9k. No, it's 9, 6 rather. Plus 3 plus 3 is 6. Not multiplication, it's addition. 3k plus what? 9. Boom. I've expanded. So I have something like k squared plus 6k plus 9. And this is over 2 squared, that's like 4 plus k. So even this guy, I'll just hold it the way it is. Then say over 2 is equal to 28. Like, I'm not really a fan of fractions, so I'm going to destroy them. Multiplying by the biggest denominator, which is 4. So that 4 can cancel out with the 4 at the bottom. Now I'll just have like k squared plus 6k plus 9. I know to be like 4 times, like, okay, if you want, let me just do this so you can see it clearly. So 4 is multiplied, puts there, then it's over 4, plus like 4 times 3, that's 12. Then minus k, minus 3, then it's over 12. Then like if I do 4 up to, okay, let me just write it so everybody can see it. Okay, so I push the screen at the bottom. I want to use the next screen. So 4 there, that's like going to cancel out to 1. Then you have k squared plus 6k plus 9. Then 2 there, 1, 2 there, what? 6. So like plus 6 times minus k minus 3. Then like 28 times 4 is 112. All right, so let's keep on going. I know this might be like a lot of work when you're doing this. Math can do a leg on you a number. But I know at first glance it might look like a handful, but the more you practice and the more you keep on watching these videos over and over again, the better you become. Just don't just watch the video once and tell yourself you have understood unless you're fully convinced that you have understood. But in the case where you have like minor questions, you can always just watch the video again, then try to understand what I'm doing. Yeah, it's not as though you don't know what to do. No. Math is literally about repeating like the same problems over and over again until you see the common mistakes that people make. Yeah, like that, you get a hang of it. So let's get back. So the 6 multiplies the minus k and you get a minus 6k, then you get a minus, oh, almost said the minus 3, 6. Anyway, it's 6 times 3, that gives you a minus 18, being equal to 112. All right, now we can take the common, oh, look at this. So you have positive 6k and minus 6k. So the k's go out, but I have k squared plus, okay, so it's not going to be a plus because I'm having positive 9 being acted on minus 18, which gives us a minus 9 being equal to 112. So I'm having like k squared is equal to the minus 9 goes that side, 112 plus 9, then I have k squared being equal to 112 plus 9 is 121. So now I'm not looking for k squared but k. So what I'll do is I'll root both sides. And I'll have k being equal to, what is the root of 121? It's 11. So plus or minus 11. This implies that k is equal to 11, or k is equal to minus what? 11. So that is how you go about solving such questions. Yeah, that's how you go about solving them. When they ask you to find the value of k, yeah, that's how you go about solving it. All right, so I guess that's how you go about everything. Okay, so what I'll do is that we'll solve, can do up one last question. Let's just do up one last question. Call it 3. So let's say if alpha and beta are the roots of the equation. Okay, if alpha and beta are the roots of the equation, 5x squared minus 2x minus 1. Then I say find the value of, yeah, let's just do up one evaluation. Let's say we have 3 minus alpha over beta minus, let's say, beta over alpha. Okay, so in most cases when you see, like I mostly say, whenever you see a fraction, look for the common denominator, because you have like multiple fractions. So the key is just to express these multiple fractions as a single fraction. So I'll be having my solution to look in this manner. So be 3 over 1 minus alpha over beta minus beta over alpha. Then common denominator is alpha beta. Now 1 into alpha beta is alpha beta, so you have 3 alpha beta. Maintain the sign, minus beta into alpha beta is alpha times 2, so you have 2 alpha. Maintain the sign. Alpha into alpha beta is beta times beta, that's beta squared. So that is what you're going to get. Okay, so I think I made a mistake. The mistake was It's going to be alpha beta here, isn't it? Then I maintain the sign. It's not really 2. Handwriting has also, Judas me. So it's not really 2. It's beta into alpha beta. Beta into alpha beta is alpha times alpha. That's like alpha squared. Then I maintain the sign. Then alpha into alpha beta is beta times beta. That will be beta squared. I hope we are up to date with this. So this will be like 3 alpha beta, but I want something to look like the sum and the product of the roots. So I will say about a -1, then I remain with alpha squared plus beta squared, like that, over alpha beta. Now I need to find the value of alpha squared plus beta squared, so I can always do up a data by the side. I told you that sometimes you can, if you want, you can just master it. So alpha squared plus beta squared is equal to alpha plus beta squared minus 2 alpha what? Beta. Yeah, I wish I've explained how to go about getting to that point. If you haven't, or if you don't understand how to get to this point, you can always watch the previous video where I did a number of questions where I was folding out these type of questions. All right, so this implies that I'll be having 3 alpha beta minus 1. Then I can just open like a square bracket and say alpha plus beta squared minus 2 alpha beta, like that. And this will be over alpha beta. Now I can always now just substitute. Okay, I have to substitute by doing just the values of the sum and the roots. Okay, now what are the sum of roots? Sum of roots means what is alpha plus what? Beta is equal to negative b over a. So from the equation I'm having, what is negative b? Negative of negative 2 over a, which is 5. So I'm having like 2 over what? 5 as my sum. And then what is my product of roots? So the product of roots is alpha beta being equal to c over what? A. The value of c is -1. The value of a is 5. So I'm getting my -1 over 5. Okay, so fractions are what we're dealing with. So from here, we're going to have 3. Then alpha beta is going to be -1 over 5, -1. In brackets, the sum is 2 over 5 squared minus 2. Then alpha beta is -1 over 5. Then over alpha beta, which is -1 over 5. Just like that. All right, so what I would do is that I'll multiply this by that. Now I have -3 over 5. Then I'll say -1. Then that will be like 2 squared, 4 over 5 squared, 25. Then this times that is plus 2 over 5. Then this will be over -1 over 5. So basically this is the same as one having -3 over 5. Then this would be like, if I multiply this times that, I'll have -4 over 25 minus 2 over 5 over -1 over 5. So I can do up a data for my numerator. -3 over 5 minus 4 over 25 minus 2 over 5. Common denominator, 25. 5 into 5 is 25. Oh, no. 5 into 5 is 5. Then it's -3. That's like -15. Then 25 into 25 is 1. So it should be -4. Then in 10, 5 into 25 is 5 times 2. It's 10. Okay. So I'm having like -29. So I'm having -29 over 25. So this means that on the numerator, I'm having -29 over 25 over -1 over 5. And this can also be written as -29 over 25 divided by -1 over 5. So I'm having -29 over 25 times let me say 5 over -1. So 5 cancels there, you get it. 5 into 25, you get 5. Negative cancels out with negative. So basically, you get your final answer as 29 over 5. So therefore, it tells you to say 3 minus alpha over beta minus beta over alpha is equal to 29 over 5, just like that. So that's how you go about solving such questions. Okay, so like I said, this could be a handful. Yeah, it could be a handful, and it could be really involving at first glance, but you get the hang of it. All right, so thanks for watching. If you have queries, you can always reach me up on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress. That's what I judge it for becoming a statistic. Let's try and push for that A plus.